Now, in order to check whether you really understand or not, let's try this past paper, AL1985 paper 2, question 2a. Form 6 students carry out the following experiments to determine the standard enthalpy of dissociation of an acid. What does it mean? Dissociation means the energy needed for ionization. How? Let's look at two experiments. For the first experiment, we have 50 cm cube of 2.0 m NaOH were added to 50 cm cube of 2.0 m HCl in a polystyrene cup. The maximum temperature rise was found to be 13 degrees Celsius. It is the ionic equation for this neutralization. For experiment 2, we repeat the experiment by using the same amount of NaOH. 50 cm cube of 2.0 m NaOH were added to 50 cm cube of 2.0 m weak acid in a polystyrene cup. In this situation, the temperature rise is a bit smaller, lower, okay, 10.5 degrees Celsius only. Given that at 298 Kelvin and 180 M, that means the standard conditions, specific heat capacity of the solution is 4.2 joule per Kelvin per gram. Density of the solution is 1 gram per cm cube. That means if you have 1 cm cube, then it is 1 gram. 1. Calculate the standard enthalpy of neutralization for experiment 1 and 2. Next, explain the difference in values obtained. Okay, let's look at this question, okay, for experiment 1. Now, energy released from the system, that means during the neutralization. Is absorbed by, is transferred to the surrounding, and in this situation is the solution. Of course, we need to neglect energy heat loss to the surrounding. Assume there is no heat loss to the surrounding, okay? And by using this equation, mc delta T, I must emphasize it is the mass of the solution, it is the specific heat capacity of the solution, and it is the delta T of the solution. Mass of the solution. What is the mass of the solution? Now, look at the situation. We have 50 cm cube of NaOH mixed with 50 cm cube of HCl. So, in the surrounding, we have total 100 cm cube of solutions. And because the density is equal to 1 gram per cm cube, therefore the mass of the solution is not 50, it is 100 gram times C. C is the heat capacity of solution, which is 4.2 joule per gram per Kelvin. And then lastly, multiply the delta T. The delta T is 15 degrees Celsius or 15 Kelvin, because we are talking about delta T, okay? Use your calculator. It is 5460 joule, okay? And then we need to calculate the standard enthalpy change of neutralization. First of all, do you remember what is standard enthalpy change of neutralization? Now let's focus on the definition. Standard enthalpy change of neutralization is the enthalpy change. To remember the format for the definition is the enthalpy change when 1 mole of water, underline, when 1 mole of water is formed from the neutralization between an acid and an alkali under standard conditions. Refer to the definition. We need to calculate the amount of heat released when 1 mole of water is formed. In other words, in this situation, we need to calculate the number of moles of water formed. So, NaOH react with HCl to form NaCl and water. None of the reactant is in excess, okay, because neutralization is just completely reacted. We have 50 cm cube 2.0 m, 50 cm cube 2.0 m. In other words, to calculate the number of mole of water, you can use the number of mole of HCl or the number of mole of NaOH. Either one is acceptable. Okay, so number of moles of water formed is equal to the number of mole of HCl or the number of mole of NaOH, which is 2 times 50 times 10 to the power negative 3, which is 0.1 mole. Now, in other words, when 0.1 mole of water is formed, 5460 joule of heat is given out, of energy is given out. Therefore, delta H5 n, bear in mind, heat is released, so you need to put a negative sign. 5460 joule over 0.1 mole. Therefore, the answer is 54.6 kilojoule per mole. Understand? That is the standard enthalpy change of neutralization for experiment 1. Next, for experiment 2, use the same argument. We have 50 cm cube of NaOH and 50 cm cube of a weak acid. Okay, so energy released during neutralization is absorbed, energy absorbed by the solution, which is mass of solution times specific heat capacity of solutions times delta T of solution. So what is the mass of solution? Which is 50 cm cube, 50 cm cube, that means 100 cm cube. 100 cm cube use density, it is 100 gram, times 4.2 joule per gram per Kelvin, times delta T. Delta T in this situation is 10.5 Kelvin, gram, and then 100 410 joule. And now the number of moles of water formed in this situation is equal to 2 times 50 times 10 to the power negative 3 is also 0.1 mole. Understand? Therefore, heat of neutralization for experiment 2, bear in mind negative sign, 4410 joule over 0.1, which is negative 44.1 kilojoule per mole. Is there any problem? Okay, now highlight negative sign. You please try, okay, again, to see whether you have missed this sign or not. Many students have forgotten this sign. Next, we need to explain the difference in values obtained. Explain. First of all, let's compare how to use a sentence to compare the difference. Do you remember? The magnitude of the standard enthalpy change of neutralization between the weak acid and NaOH is smaller than the magnitude, more than that, okay? The magnitude of the standard enthalpy change of neutralization between HCl and NaOH. Highlight the magnitude. We compare only the number, okay? Omit the sign. After that, we need to explain, because as in experiment 2, the weak acid is only partially ionized to form hydrogen ions. Okay, originally it is incompletely ionized in water. Therefore, some energy are absorbed for what? To ionize the weak acid for the neutralization reaction. Do you understand? We need to force the molecule of the weak acid to ionize further, to ionize completely to form hydrogen ion for neutralization reaction. Energy is needed. Okay? So, let's look at the last part. Calculate the standard enthalpy of dissociation or ionization. It stands for this reaction. This is called dissociation or ionization of RCOOH. How can we work this out? It's not difficult, okay? Copy down the question first. Standard enthalpy of dissociation of RCOOH is equal to the difference between these two values, negative 44.1 this is the first number, minus 54.6, which is 10.5 kilojoule per mole. Again, take out a highlight pen. Please tell me why the answer must have a positive sign. Must have a positive sign. What is the meaning of dissociations of acid? Dissociation, that means we need to break OH bond. Break. Bond breaking is endothermic. Endothermic, not exothermic. Do you understand? Okay?